make that available for you guys. Okay. While that's going, I'm talking, I'm also going to plug this in. I'm about halfway down on power. Just be careful here. All right, so again, now's the time for you to actually shift your thinking just a moment. Not necessarily have to worry about Grasshopper too much, but think about, well, how do I design my own shading component, right? Realizing that you can't use the same double, two-sided pyramid form that you just did over the weekend. That's too simple, and you've already done that, and so I want you to come up with your own. Let's just talk about the process I want you to use. All right, so just as I mentioned, now's the time to design your own shading component, which later will be built in Grasshopper. But to start with, I want you to sort of think in terms of paper and folding. Right? I mean, the logic here is that these are going to be fabricated out of paper. We have to take something digital, virtual, but three-dimensionally defined, and then flatten it out in order to use planar fabrication methods like laser cutting and other sort of CNC methods, right? So if we start with something that starts flat, and then we create something three-dimensional from it, then it already has that logic built in that we can take it apart and flatten it back out, and it can be made out of planar components, right? This is actually how, again, if you're thinking about material engagement or some of these material properties, this is one way to, again, bake in the sort of logic of planar componentry, creating three-dimensional things, right? Sort of the flat packed components that then create something three-dimensional, flat to fat, if you will. All right, so with the component prototyping, I recommend just using non-lined, just regular old printer bond paper, just an 8.5 by 11 piece. I've actually given you a quick recipe just for your first sort of set of studies. Things that you can do, and with 30 seconds you can have a very quick study model. And if you do it this way over and over again, you have a series of study models that are all the same size. So when you line them all up and take a nice photo of all of them, the good, the bad, and the ugly, right? It looks like you were sort of systematically studying these things with a little bit of rigor and attention to detail. So anyway, if you just take 8.5 by 11, you just measure out an inch and cut off a strip. You fold it in half and then fold it into quarters. Then suddenly it becomes very easy to just simply simulate a quad, right? Just one quad. Could be one quad out of 100, or what's 11 times 11? 121, or 12 times 12, 144, whatever it is, right? But just one quad. Just start with one quad. We just make one component, and then the repetition happens later in Grasshopper, right? So all we have to do is design one of these. Then with the offcut here, that's now 7.5 by 11, you can fold into half the other way, fold it into quarters, right? Now suddenly you have a set of modules and edges that actually line up with edges on the frame, and you can start to quickly make cuts or folds in order to sort of think about your own sort of shading component. And again, the spirit here is that, yeah, it might look a little janky at first, right? I mean, let's be honest, right? Like, paper is kind of flimsy, and if you were cutting a straight line, or kind of gets a little sideways on you, right? Like, it could look a little messy. But the idea is rapid iteration, very, very inexpensively, right? Like, I mean, if you need printer paper, I can go down the hall and steal some out of the office and hand you some. It should be again, so quick and easy that you have no problem making 30 of these if you really wanted to, right? Now, I would say that I only want to see one, right? But I want to see one where you've really started to explore this and make something interesting, right? So here's the sort of recipe you can use. And then here's, some examples of things in the past. There's other, different colleagues of mine, buddies, that sort of looked at this problem overall. I would say some of these are kind of interesting, but a lot of them don't really give you much aperture. In other words, they don't really, if this is going to be eventually a screen, right? I would think in terms of maybe I remove these two so that, I have a bird's mouth I can open and close. More open, less light, more light, more view, less view, etc. Right? So you can always think parametrically about these things anyway. And then finally, just really quickly, some of you were in my office just a minute ago during office hours when I was just quickly sketching this out. Right? I'd like for you to sort of, again, sketch. From here, this is what I need to then implement my idea in Grasshopper. And I'll do it right now in front of you, right? But I have a quad. I'm going to place a point. I named the vertices. I place a point in the middle. That point's going to give me a U line and a V line, isoparm, right? The latitude and longitude. Then I can project up along the normal and get a B, an apex point. And then I can start to place points along these U's and V isoparms. Right? C, D, E, F. And I label them each time. And then when I get to here, I just sort of say, okay, I need to connect the dots with a triangle. B, V1, D. B, V2, D. B, V2F. B, V3F. And I'm just sort of listing these out. Really, because at that point in Grasshopper, I just have a big spaghetti bowl. And if I actually label all the points, just like I am here, then I can just make something and say, okay, I don't even have to think about this now. I've worked it all out here. B, E, blah, 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 right? Just sort of connect things up. And it'll all just work, right? Should I demonstrate this, right? So this is what I'm asking for. A diagram, sketch. Try to sketch nicely, right? I mean, you guys, it seemed like maybe in second year they sort of like try to get you to draw things like by hand. Maybe to the chagrin of me, I want you to use Rhino and Revit and laser cutters and just make stuff, right? But so again, just think systematically, right? Like I didn't just start drawing things at different sizes. I made a little grid, right? I tried to make things align. 1, 2, 3, 4. And then when I get to the sort of master diagram, I'm ready to sort of take the whole page. Right? So, craft, care, intention, detail, right? Okay, it all starts even when you're sketching in your sketchbooks, which this is quite literally one of my sketchbooks. You guys ever do that? Like you guys do a sketch a day or something? I have to sometimes because I've gotten bad about it, but if you think about it, it's like it's better than just like vegging out for Hulu or something. So anyway, yeah. All right. So this is what I'm asking for. Try to use paper. Try to prototype something that you think could be really interesting. Then try to sketch it out and sort of say, here's how I built it parametrically, right? If I was going to draw this by hand, right, I have to find the midpoint and then project things out, and then I'm just sort of step by step doing this, just like if I was modeling this in Rhino or you're using my parallel bar back at home. This is the glue. This is like the sort of turning point, right? If you do a good job here, and we'll talk about these on Wednesday more, right? Then over the weekend, you're ready to launch back into Grasshopper and modify your Grasshopper graph, get rid of that stupid two-sided pyramid thing, and start to make your own. You already know how to break up the surface into quads, and then it's like breaking the quads into each quad into its constituent edge, face, edges, and vertices, right? And then you can start, with each of those faces, right? Those are each quad surfaces. You can start to plot points on them. You can project them up or down, right? You can start connecting dots, right? Yeah. Right. So this will be my demonstration today. I'm just going to demonstrate this. Like how do I use this and go from here and then start to implement it in Grasshopper. Let me just zoom out here a bit. There we are. Yeah. And look, this is the important part. Before you anybody ever like code something? Like write scripts, write code? Anybody ever have to do that? Yeah, okay. You know what you do first? You write things out like step by step what you think you're going to do in plain language, natural language, right? So you're basically writing yourself a pseudocode or a prompt, right? Where you say, first I need this, and I'll use this, and I'll make this, and I'll use these for the next ingredient for the next step by step, how I'm going to build this. And I'll refer back to it as I go. These are my step-by-step instructions. I'm a very visual person. When I go to IKEA or buy a set of Lego, I like the visual instructions, right? It'd be terrible if it just said, like in written language, just like trying to tell me what to do, right? So this is really important, right? And again, I think it's a interesting and needed reminder that every representation you draw, every drawing you make, you produce, is meant to communicate your design intentions to someone else who's going to build it, or make the parts, or put them together on site, right? And when people are putting things together on site, it could be that it's, in Las Vegas, it's 108 degrees outside, and there's no shade, or there's windy and there's dust everywhere, or it could be somewhere out east where it actually rains, and it could be in ankle-deep mud in a hole in the ground, trying to figure out how concrete's poured, whatever, right? What we do, we don't build buildings, we make drawings of buildings. And those drawings have to sort of communicate what they're making, right? So again, just a friendly reminder, and I hope that this is helpful. All right, first things first, I'm gonna make a surface. I don't care what surface it is, right? Because the important part is I'm making my own tool, my own graph. They'll take any surface I give it and break it up into quads and columns and rows. And how many? It's a slider. I can change it. It's a variable, right? And what do I populate it with? Right? That's something I'll do in front of you. But then I can plug in any surface, and it'll break it up into columns and rows and quads and populate it with my shading components, right? Yeah. In fact, next week I'll give you a specific surface to use. I don't care what surface you use from now. So I'll just maybe make a couple just to sort of show you that, right, to demonstrate that. I'll start with just something that's plainer, a little plain Jane, corner to corner. There we go. Maybe I'll also give something with a little bit of double curvature. There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and just drawing some Bezier splines. Good old Pierre. I'll just move these out and space them out so I can use some good old loft. Right? All right, there we go. Yeah, we can tell that has some pretty crazy curvature to it, no? All right. So I can use any old surface and it doesn't really matter. All right. Oops. In fact, if I click and drag by accident. So while Grasshopper's firing up, I'm just going to pull out my mouse so I don't have any more strange dragging accidents across the screen here. There we are, Grasshopper. So, first things first, I can take any surface that I modeled in Rhino and I can bring it into Grasshopper and start to build off of it, right? So let's go ahead and do that. The params tab, geometry, right? Just about literally any kind of geometric object you can place natively in Rhino. There's a placeholder widget for it here, right? Points, curves, lines, boxes, P-wraps, which are a fancy word for surfaces and polysurfaces, and meshes and sub-Ds and blah, 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 blah. All right, so we have a surface. I'll just use surface. And I'll place that, and when I right-click on it and say Set One Surface, Grasshopper disappears, allowing me to look around in Rhino, select something in Rhino that I want to bring into Grasshopper, right? I reference that bad boy in. There we go. All right, and now, not only do I have that gray Rhino representation, but I also have that reddish-pink Grasshopper representation. Yeah, man, can't wait. All right, so quick rehash of what you guys did over the weekend. If you think about a surface mathematically, topologically, if you will, it's a two-dimensional surface. We can map along two different directions, a U and a V. I know in XYZ space it's three-dimensional, right? It's curved and everything else. But if we're going to place something inside of this geometry, we simply need two dimensions, two coordinates, in fact, U and V. A line is a one-dimensional thing, right? We just have a T address. But for surface, Now, if we think about this just for a moment, let's think about this like an Excel spreadsheet that we printed out on a piece of rubbery paper, and now we're stretching it to make this shape. We would have A1 all the way to Q39 or something, right? And the alphabet would go A, B, C, D this way, and 1, 2, 3, 4, 5 in this way, right? Now, if we just simply assign a U and a V, then we go 0, 0, 0, 1, 1, 0, 1, 1, right? If we want halfway, it's 0.5, 0.5, right? We just need to give it a latitude and a longitude. And if we can presume that the start is 0 and the end is 1, then it's really easy to find halfway points. It'd be 0.5, or quarter points, 0.25 and 0.75, et cetera, right? So what we're going to do is we're going to look at this mathematically, and we're going to say, well, what we have here is a two-dimensional domain. A domain being a minimum, maximum, right, 0 to 1, and then a second dimension, 0 to 1, and the opposite, the U and the V, right? So we're going to go ahead and plug that in as the two-dimensional domain, and then divide it. How many times in the U direction, how many times in the V direction? Let's make a number slider and make that parameter a variable that we can always tweak if we want to. I'll constrain it to integers. I don't necessarily want 2.5 cells or 2.39 cells. I either want 2 cells or 3 cells, right? So I'll constrain it to basically whole numbers. Never divide by 0. We can't have 0 cells. That would just be mathematically stupid. But maybe I'll go up to, let's say, 15, 1 to 15. Once I have that set, I'll make 2 copies, copy and paste. And, right. Now, all it's doing is it's taking the mathematical domain, 0 to 66 points, blah, 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 and 0 to 89 points, blah, 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 blah. And it's dividing each direction 6 times and then 4 times, and giving us a list of two-dimensional subdomains. Now we're going to use that list and say, let's divide up this surface with those domains. So we go to surface. It's kind of a weird thing to do. I'm not going to lie. But here I'm going to plug in that surface and plug in those domains. And now let's just turn that preview off for a second so we can see maybe just a little better. I'm going to go ahead and turn this layer, default layer off, just so we can see the grasshopper stuff and we can see that grid. And as I start to change this, now we have a different set of dimensions each time. I'm just going to set that to 2 and 2. Let's start really simple, right? 2 by 2 grid of quads. All right. That way I can sort of more easily see what I'm doing here. All right, well, I have a quad. I have 4 quads, actually, in number of quads. Let's see what my instructions tell me to do. Here we go. I'm going to take each of those quads. I'm going to find the sort of midpoint, the sort of centroid of that area, that shape. Right? So I'm going to go in the U direction, 0.5, and the V direction, 0.5, and find that sort of middle point, that center point. Beautiful. I think that's a great idea. I'll just do that really quickly. All right, so I have all of these subsurfaces, right? 4 of them. What I need to do is I need to explode them and find the sort of constituent edges, vertices, and faces, right? From there, then I can start to use all those ingredients, points, curves, surfaces, to start to build things, other things, right? Smaller things. Make it more complex. All right, so that's why we then use this deconstruct brep, which then takes each of these quads and I get their faces, their edges, and their vertices in a nice ordered way, right? It's very, very handy, actually. All right. Yes. Can't wait. All right, so the faces, those are the surfaces. Let's go ahead and find a UV parameter along them. And look, I can do it with evaluate surface, right? I'll plug these faces in. I'm going to right-click and say, let's see, right-click on there and say reparameterize. I want it to reparameterize it 0 to 1, 0 to 1, sort of normalize the U and V for each of those, right? And that makes it really easy to use a multi-dimensional slider right out of the box. The sort of generic 0 to 1, 0 to 1, centered at 0.5, 0.5, and plug that in. And now, I have those middle points, right? Yay. Now, I could also and look at the instructions I made. I want to find the U isoparm and the V isoparm at that point, right? So I want the equator and the prime meridian, because I'm going to use those later on to start to place more points along that surface. All right, so here's an interesting method for that. If I go to curves, I think I showed this the other day. It's not necessarily obvious though, so I'll show it again. And I go to splines and I find isocurves, right? Those are the isoparms, right? The curves along the surface. Think of those as latitude and longitude lines. And if I click that out, it's going to give me a U isoparm and a V isoparm, an equator and a prime meridian. And all I have to do is give it the surface and give it the UV parameter. I'm going to use the same UV parameter that I did over here. So if I move that around, it'll change on all of these widgets. I'm going to right-click and reparameterize and then plug my surface into my faces into these, my quads. All right, now I have a U and a V, right, for each of these. Hooray, yes. Incredible. All right. Now, I'll zoom in a little further. I'm going to go ahead and project that middle point up. Yeah, create some sort of apex, just like we did for the pyramid. So I can do start point, direction, length, finding the normal to the surface, using the same method that I find the point, project upwards. Right? But I'm also going to place points along the equator and the prime meridian I just generated, right? So I'll find a t parameter, and then put one equidistant on the other side from the edge. I'll subtract that t parameter from 1, and then I'll do the same thing for the V isoparm as well. All right, so let's see what happens when I do this. And maybe it makes a little more sense when you see it in action. All right, first, here's my frame, my normal, and my point. Let's see, I'm going to go ahead and say start point, direction, length line, using this start point, using the normal as a direction, and then for a length, I'll go ahead and plug in a number slider. I'll go ahead and double click on that number slider and change its properties and give it a different minimum maximum. Let's say -20 is a minimum and +20 is a max. Some of you noticed that depending on how you modeled your curves, drew your curves, and then lofted a surface, sometimes the top of the surface is pointed downwards, sometimes it's pointed upwards, right? So some of you are reading things and going, why is this on the other side, right? Well, if you wanted to solve that, you could just simply go in the negative or positive. In this case, the negative for me. Look at that. Hot damn. All right. And then last, I just want the end point of that new line that I drawn, right? That apex point. So I'm just going to look at curve and find its start and end, and there's the end point, and that's exactly what I want, right? So that end point is B on my diagram. Oh yeah, look at that. All right, now, let's start adding some things along these U's and V's. Remember, we did this in the trusses, right? You want to snap a point along one of these lines, you give it a T address, a T value, right? So it's a street address. So let's see, we have this U line and we have this V line. Let's do one at a time, one first. We'll go to the curve tools and we'll evaluate the curve at a T parameter. I'll plug in this U. Okay. I'll go ahead and reparameterize it so the starting address is 0, the ending T address is 1, halfway would be 0.5, a little bit of the, etc. Okay. That way I can go ahead and use this number slider and to my full advantage here. Okay. Now, instead of just plugging in one U curve, I plugged in 4 because I had 4 quads, right? So I have a data tree, and inside each limb of the data tree, right, I have a different U curve and a different V curve, right? So now I can place a point on each quad in the exact same place, right, along it. Now, I wanted to just move at the most halfway across this, so I'm just going to double-click this and constrain it to, let's say, 0.49 or something, so it can't quite go all the way to the middle, but it can open and close this way. Now watch this. Let's say I want to make a point on the other side of the quad, right? Let's say right here, that also moves in and out, away from the edge, closer to the edge, but the opposite direction of this one. It's just a little bit of math. What I'll do is I'll say the end is 1, right? So if I take take a subtraction widget and I say 1 minus whatever this is, right? This is a variable. Okay. Then I can do the exact same thing. I'll just make a copy of this and I'll plug that in for t. Aha. Watch this. Oh, this is so satisfying. Yeah, now you can see where we're going, right? Just simple connecting the dots. Yeah, a little bit of math. Arithmetic even, nothing complex. Now, let's say I want to make a copy of these, but then plug in v instead of u. Oh yeah, this is where it all comes together. This made it all worth it. All right. The sound effects, of course, are always optional. I don't even realize I'm doing them, sorry. I'm not trying to be that stupid, but let me go ahead and turn some of these things off so we can see a little better. Yada, 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 blah, blah, blah. All right, so here we go. These and these. And oh yeah, look at that. Okay. And of course, we can move this up or down as much as we want. So, I've labeled each of these, and I've generated this point, 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 this point. At that point, what I can do is I can go to my diagram and say, I'm just going to go and label each widget with these labels, and then later on, when I make a triangular surface, like let's say the fifth one, I just hook up E, Y3, and C, and I'm done. I don't have to think about it and try to click on things, trying to figure out which one is which. Really disturbing to be that close to this thing that's bouncing up and down. Like, makes me dizzy. But, all right, so bear with me as I do that really quickly. All right, just as you did before, right? We go back to these vertices, and I'm going to pull out the first vertice, and the second vertice, and the third vertice, and the fourth vertice from each of these quads, using the nth item in a list, right? Where we change that index. So the first one will be an index of 0, the second one will be an index of 1, third one will be an index of 2, fourth one will be an index of 3. So we'll plug these in. There's my V1. In fact, I'll just change it to V1. All right, now I got to change the what do you call it here? V2. The index number, right? And then I'll also change the label. So V2, V3, vertex 4. Oh yeah, okay, great. So halfway there, almost halfway there. This is the endpoint. So I'm going to name this B, because that's B on my diagram. I'll go ahead and pull these out so I can just, again, have them all in a nice line for me when I'm making a bunch of triangular surfaces here. All right, and now I have these, right? So here's vertex 1, vertex 2, vertex 3, vertex 4. I believe probably that this one should be 2 and this one should be 4, so I'll go ahead and do that just so it corresponds to the exact same ones here. Oh, why did I do that? Here we go. I also turned off the preview on these for some reason. There we go. 1, 2, 3, 4. Yeah, I like that. Okay, and last but not least, I have C, D, E, and F. All right, fair enough. There's let's see, there's C, and there's D, and let's see, E is down here, and then up is F. All right, so E and F. Again, at this point, my brain is like mush, and I just want to connect the right things up, because look at how many points there are, right? Connecting the dots, but let's make it easy. If I figure it out on paper, it's a hell of a lot easier, right? Okay, and so last but not least, I just need to make surfaces. Here we go, surface from 3 or 4 points. That seems particularly useful at this point. just shrink this down just so I can see enough of this. And here we go, triangle 1. All of them will have B, we know that. Okay. And let's see, V1, B to V1 to D. Yeah, look at that, nice triangle. All right, now I'll do it again. B to V2 to D. All right, so V2 and D. All right, starting to take shape now, huh? I can tell you guys are excited by the blank stares, but it is Monday, I'll give you that. All right, triangle 3, B, right? So at this point, I'm not like playing a guessing game. I just have everything labeled, everything in its right place, which is nice, right? If you don't figure this stuff out, nobody on the construction site wants to do it. They'll charge a lot more if they have to figure this out, and it won't be exactly what you want, right? So you got to figure all this stuff out and have answers when anybody asks. Oops. Of course I did. There we go. Starting to get there. Look, watch. It's like grasshopper calisthenics, right? Open, close, open, close. All right. I can't wait. 2 more, right? No, 4 more. Yeah, 4 up here and then 4 down there. Let's just move this over. I just have to finish this now, or it'll just really bug me. And in fact, I'm just going to copy and paste this. Let's start plugging in all the B's. We know that we need B's for all of these. All right, V3. That one has a V3. And then this one has a V4. This one has a V4. And then this one has a V1. And then CC and EE. All right, CC. And EE. Oh, yeah, look at that. How do I, sorry, I'm just trying to, yeah, okay, here we go. My cursor wasn't really showing, but okay, there we are. Yeah, right. So now, this is my shading component, and I can make it more or less of them, depending on how many I want to actually laser cut. And I can make them taller and more pronounced, spiky, if you will, or less pronounced. Right? I can even put them to the inside or the outside, right? And yeah, I can then open them up or close them depending on what I want to do here. Yeah, all right. So let's see, I'm gonna turn the preview off there so we can sort of look through this thing. Yeah, not too shabby. And look, I mean, if I wanted to, again, I just come back here to the left and say, set one surface, let's put it over here instead, right? Yeah, sure, why not, right? I mean, give me a surface, I can break it up into quads, I can populate with my shape period, right? It could be a tower cylinder shape, it could be a box, it could be a plane, it could be something wavy and curvy, it could be topography, whatever, right? But that's 4 sides, I can break it up into columns and rows, populate it, right? Easy peasy. All right, and then from here I can bake this and lay them all out, flatten them, make sure they're labeled, laser cut, etc. Right? Now we'll talk about how we can automate that in Grasshopper later. But for now, it's not a trivial problem. You have to then come up with, how do I take a quad? Where do I need points? Do I project up or down to give it some dimension here? What are the parameters? How do I just take a piece of paper and start folding it, right? I don't worry about every little tool in Grasshopper yet. How do I take a piece of paper and do the same thing? Now, how do I step back from that and actually draw a quick diagram or sketch, right? And show how that thing's built and how the height is variable and how it opens and closes. That's all just governed by sliders. They're variable. I can change them anytime, right? Okay. You get that part, that's the interesting part, that's the design part. Then we can figure out over the weekend, starting over the weekend, how you build it in Grasshopper, right? And some of you will pick it up really quick. Others, it'll take a little longer. I get it. Not my first rodeo, I know. Man, just think of it like, it almost looks like something out of Palm Springs in mid-century. You put it on a planer thing, right? Like I just cast this out of plaster or concrete and just make a series of breeze blocks and start stacking them or something. But we'll actually do something on a curved shell form, right, later on. But again, remember, it doesn't matter what surface you plug in. You can plug in any other surface later on. What you're doing is you're making the recipe. It's like when you bake cookies and it says, use your oven. You go, oh shit, I'm at my grandma's. Can I use her oven instead? Right? Yeah, you can use any oven you want, right? In order to make the cookies. Same thing here, right? The starting ingredient is a surface. It can be any surface you want. It has 4 sides. They can break it up in columns and rows. Okay? All right. I brought examples of grid shells that people laser cut and put together the last time. Right? And maybe soon I'll bring another set in, just in case you can sort of refresh your memory. How goes it in finding, some chipboard? Anybody been looking around for chipboard yet? Online, in Valley, in person, whatever? I recommend trying to get something thin. 0.020 will give you the most flexibility, right? Because what you'll begin to notice is just like this isopar, the depth of it, you can laser cut that curve. But then there's also the other dimension, the other direction where we'll need to flex, right? And so if it's not laminated, if it's single ply, if it's thin, then it'll give you that flex and be easily worked out as you start to put all the slots and things together. It starts to actually take its shape, right? I'll talk a little bit more about this once we actually start to laser cut. And, we'll take the surface that you populate with your components, and we'll talk about scripting, and I'll give you a script that you can run and execute that will then create the structure and lay it all out with notches and labels, just to sort of demonstrate that process. But when we get there, I'll also talk about how to put it together, because it's not a trivial thing. You start to put these things together, and you start to put more further on down the other ones once it sort of come out, right? So we'll talk about how to sequence these things. So you're thinking a couple steps ahead on how you actually put this thing together, which you have to do, right? It's something similar is like when you draw a really nice acute angle in like a plan or something, and your professor comes and she says like, well, how do you get a screw gun in there to actually put the drywall? How do you swing a hammer in an acute angle, right? You go, oh, I don't know. You go, and then you start running down the hallway screaming. And you calm down, eventually come back, and you start to really think about how something might go together and how you make it easy to put it together instead of hard. So people aren't on the job site cursing your name and thing. Okay, so, got it? All right. So baby steps. What I'm asking you to do between now and Wednesday, get a piece of paper, cut an inch strip, fold it into a little frame, right? Tape it or whatever. I recommend just using some clear Scotch tape. And then you'll have the offcut, and you can cut it, fold it, however you need, right? And take a photo of what you have when you're happy with it. Right? Some of you will have stuff that's way too complicated, and I'll be like, let's peel this away a little bit, but because you're going to be laser cutting it, it's going to be this big instead of this big, right? Yeah, right? And then to try your best to sketch it out. Take a photo of your little prototype, or if you have a series of them, take a nice photo of the series of them. I don't care. That'd be great. I mean, lay them out in like a little axon and get some good lighting, and make sure your Mountain Dew bottle and your bedspread is like in the background. Like take a legit photo, right? Again, everything you submit reflects on you. I get paid either way, but if I see like garbage in the background and like the lights were turned off so everything's grainy, I'm gonna be like, well, this looks awful. Can you retake this and try a little bit? So always think about this stuff, right? How this reflects on you. But take again a quick photograph of your prototype. Try a sketch. Try sketching this out. Might be a little series of step-by-steps like I did, or it might just be one, big one, or whatever. But take a photo of it. That's what you need to upload for Wednesday. Okay. So you see paper prototype, photo, and diagram is the assignment for Wednesday. And again, here's an example of the sketch. Example of, let's say, a prototype, or in this case, a grid of sort of ideas. But I just say pick one and then really go with it. And look, this is like an ancient process. Like, I mean, people have been screwing around with this forever, so you're not going to come up with something that nobody has ever done before. In fact, you've never come up with anything that somebody in this class hasn't done before the last 3 years. Okay? Honestly. Right? So just go with something you like. Yeah. And look, it doesn't have to be very complex. So when you start to pile them up in a 10 by 10 matrix, right, the repetition actually starts to lend that sort of new set of complexity, new reading to it. So it can be actually not too, I wouldn't make something too convoluted, in other words. Okay? And in fact, that's why I want to have that conversation with you on Wednesday before you start spinning. I don't want anybody spinning their wheels over the weekend. Right? I want to make sure you have something that you'll be able to sort of model. And then the other thing to think about, and I'll have this in the back of my mind as well, the scale that you're going to be prototyping these things and laser cutting and folding thicker things like chipboard, right? So again, some of you will have like lots of detail that would be almost microscopic by the time you get to the end. I'll just sort of, again, help me, right? Think about where I'm coming from. I'm just here to help you. If I just say, simplify this, take that away, you have 18 folds here, you're never going to be able to fold a little checker of chipboard 18 times in different, to make that corrugation. Simplify it, make it 3 times, 4 times, whatever matters, right? Or think it 2 times, and then, but you're going to have like 10 of these by 10 of these, so you'll just have a different effect, the similar effect at a different scale once you actually start instantiating across the entire system, right? Anyway, right now you're just going to say you've made a component, right? Just a 2-sided pyramid, and then it also makes a system that shows these things populating a surface. Now it's time for you to make your own component between now and Wednesday. And then Wednesday to Monday and a little further on, right? Some of you will need more time, that's fine. But over the weekend, then you'll put it into Grasshopper so you can generate the system again, right? See what the piece makes. The system that the little piece makes. So part to whole. Okay. All right. So again, just want to reiterate, right? Like Wednesday, try to get caught up if you're a little behind, but definitely get a piece of paper. Again, try to get a piece of paper or 2 or 3 or 4 or whatever. You don't have to beat it into the ground, right? But like if you have something that's interesting, just stop, take a photo of it, start sketching it out, try to figure out how you would geometrically make it, right? Again, this is made for just, again, very quick, very easy. You don't even need an X-Acto knife. You can just use scissors or just fold things over a couple times until you can sort of gently tear them precisely or whatever. But just simply quick, rapid iteration, right, if you need it. Particularly at the beginning of a design problem, right? That's where we think about divergent thinking, rapid iteration, brainstorming, lots of different prototyping, giving you a wide array of things to sort of evaluate before you pick and then start to converge into something that satisfies all the fitness criteria, right? Yeah, all right? So now's the time to cast a wide net. The logic's built in. If you just can make it out of paper, then you can flatten it back out, laser cut it, make it out of chipboard. But instead of making 1, you're making 10 by 10 of them, 100, right? So keep that in mind, right? The more convoluted it is, right? It might be easy to make 1 at this scale, but to make 100 of them at this scale could be really difficult. So keep that in mind. That's the sort of filter or lens. I'll be looking at these a little more skeptically on Wednesday with you, okay? Those who are ready. Should we just call this early? Let you guys work? All right, sounds great. Well, I'm around for the next 10 minutes or so. If you need anything, just come on up and Like I said, if you want to talk about your project one submission, that's fine. If you want to resubmit, that's fine. But a lot of you did really well. If you have any questions about this or what happened over the weekend or whatever, it'd be a great time to hit me up. Okay. But if you want to